First, I want to say thanks for everyone coming. There are some awesome talks happening at the same time as this, so I'm really impressed that there are people in the room and all you showed up. So there's some other great speakers, some other great topics happening at the same time, but I guess through the magic of the internet and YouTube, you'll be able to watch those as well. So I appreciate you coming to choose to watch me talk. So what are we going to talk about today? We talk about Spring Cloud, and this is kind of an introduction to Spring Cloud and help you get started using some of the awesome features that we have to offer in the Spring Cloud project. So first, I'll introduce myself. My name is Ryan Baxter. I am a rookie engineer on the Spring Cloud team. I joined a little over a year ago from another very small company called IBM. Where I was actually playing around with, or first introduced to Spring Cloud while I was working at IBM, and I was playing around with it and first discovered Spring Boot and thought that was super cool. And then as I got more involved in the cloud space, I came across Spring Cloud, and that was even cooler. And I started to issue pull requests and so forth and so on in the project, and they eventually asked me to join Pivotal. So I gladly accepted, and here I am today. And it's kind of ironic, given the announcements of Pivotal and IBM partnering in some aspects this morning. That's kind of cool. Outside of my work, I'm a father and husband to two kids and a lovely wife. And when I'm not doing that or working, I train for obstacle course racing. That's what I'm doing in that picture there. Yeah, so I'm a lot of training outside of work and fatherhood and husbandhood and stuff like that. If you want to get in touch with me, you can reach out to me. The best way to do that is on Twitter. I'm at Ryan J. Baxter on Twitter. That's the best way. Of course, you can always find me at the conference. I'll be here for the rest of the week, but if you want to get in touch after that, that's the way to do it. I have a blog at ryanjbaxter.com where I talk about some of the stuff that we're going to touch on today. So feel free to check that out as well. So this is pretty much what we're going to talk about today. This is what the topics we're going to cover. Pretty straightforward and simple. We're going to talk about the background, the reasoning, the history of Spring Cloud, why you want to use it, where it came from, why it's important. Then we're going to take a look at some of the key projects that most beginners tend to gravitate towards when they first starting using Spring Cloud, what they do, how they can help you in your cloud native journey. Then we're going to get down and dirty with Spring Cloud. We're going to do some live coding, show you how it actually works in practice, and then we will have some time for questions, whatever questions anyone has after that. But first, I just want to ask you guys a couple of questions. So who here is familiar with Spring Boot and Spring and all that? I assume everyone, right? All your hands come up, OK. Has anyone played around with Spring Cloud yet? OK, that's good, right? If you are experts, you shouldn't be here. So if you are an expert in Spring Cloud, you can probably go to a different session because it's going to all be a review. So that's good. And then the last question I have for you guys is, who here knows this guy? Has everyone seen Josh Long speak before? Josh is actually giving a talk at the same time, so I'm really impressed that you came to my talk instead of his talk. But Josh is a great colleague of mine. When I was getting started learning Spring Boot and Spring Cloud, I watched a ton of his videos on YouTube. And the great thing about Josh, if you've never seen him speak, is he's an excellent presenter. But he's truly motivational, right, as well, right? He really gets you excited to go off and try the things that he talks about, and he makes it look so damn simple, right, and easy. And then you sit down at your computer and you start to do the stuff that he was doing, and you're like, what the hell did he just do, right? I'm completely lost, right? It was so simple when he did it, but now I can't figure it out. Am I dumb or something? No, it's just Josh is great, and this stuff is not that easy. And so the goal of this talk is to kind of make us like Josh Long, right? So that it is actually easy, and you can grok it, and it's easy to understand. Oh, I got to hold on. So why Spring Cloud? In general, I think we can all agree at this point that building or cloud native applications are a good thing, right? If you're going to run applications in the cloud. It's just not easy to do, per se, right? When you're a gigantic corporation like the Googles, the Facebooks of the world, the Amazons of the world, you have a lot of resources to put behind these projects and to build out these cloud-native applications. And the resources in both time and people and money, and they can do a lot and get a lot accomplished pretty fast, right? But when you're not someone with those types of resources, what are you to do, right? You need to produce at the same speed and cadence that these larger corporations do, but you don't have those resources. And they've done a lot of great work, right? They've done a lot of stuff to show us how to build these cloud-native applications. And some of them, like Netflix, have even produced open source libraries that help you do so. But why do we have to, kind of reinvent the wheel every time we want to go and use these things? So following the Spring Boot model of doing things, we kind of provide an opinionated way of building. Spring Cloud provides an opinionated way of building cloud-native applications with a bunch of useful defaults, right? You can add dependencies to your class path. You can stick a couple annotations in your code, and all of a sudden magic happens, right? And things start to happen. And if those defaults don't suit you for your needs, you can easily configure them and switch them out to do what you want, right? So it's the same approach that Spring Boot has for building Java applications, but for cloud applications. And we are cloud agnostic, so we don't really care where you run your application, right? At the end of the day, your Spring Cloud app is going to be a jar, just like a regular boot app is. And wherever you can run a jar, you can run your Spring Cloud app. Or if you really want to package it as a WAR, you can do that too. But jars are cooler. So let's take a look at some of the components, the core components that make up the Spring Cloud ecosystem, per se. The first one is configuration. So this is a kind of a key one. We're all familiar with configuration today. It's an important part of building applications. But there's some nuances that require, that would require your application to behave a little bit differently in the cloud as far as configuration. So we have Spring Cloud config server and config client, which allow you to kind of centralize all your configuration for your cloud-native applications in a single spot. Service discovery is another topic that everyone kind of needs in every cloud-native application. So you have a bunch of microservices that are going to make up your cloud-native application. They need to talk to each other, and they need to know where they live. And because of the dynamic nature of the cloud, that might change from time to time, and things about those different microservices can be quite dynamic. So service discovery helps you solve that problem. Circuit breakers, another cool feature and important feature in building a cloud-native application. Circuit breakers help protect your application and your users from failure. So failure is going to happen in a cloud environment. And these circuit breakers can help insulate your clients, your users, and yourself from these problems. Routing and messaging, this is probably the backbone to any cloud-native application. So your microservices are going to have to communicate with each other in some way, right? You're going to be making API requests between the different microservices. So having a way of routing your requests and sending asynchronous messages or whatever it may be is quite important. An API gateway. So whether you actually are going to have a public API for your cloud-native application, or it's just your front-end client that's talking to the cloud-native application itself, an API gateway can be quite important. It's going to route requests from your clients off to the various microservices back behind your application for you. Tracing. So tracing is not fairly new, but it's something kind of new to our Spring Cloud project set. And this wasn't originally here when I first started playing with Spring Cloud. And what I often ran into when I was building applications was problems debugging it, right? Because you're going to have a lot of microservices and you're going to have those microservices talking to each other, and requests can go from one to the next, to the next, to the next. And trying to find where the problem can be hard, to say the least. So tracing helps you do that I guess, in a more easy fashion. And then finally, CI pipelines and testing are very important, right? From a CI pipelines point of view, you're not going to really be a true cloud native application with all the flexibility that comes along with that if you can't automatically build and deploy your applications. So our CI pipelines project does help you do that. And testing, right? We want to be able to test not only the individual microservices themselves, but the contracts that these microservices have between each other. So this is another important piece and fairly new piece to the Spring Cloud project set that we're going to talk about today. And there's much more, right? There's a lot of stuff under the Spring Cloud umbrella or GitHub organization, if that's the way you want to look at it. There's Spring Cloud Bus and Stream and Data and Task and AWS and Function, and it's always growing. There's a lot of stuff going on there. And I'm not going to talk about all this. I'm going to talk about the ones that I think are important for beginners and people gravitate towards as far as just getting started. And the other reason why I'm not going to talk about these is because there's other sessions at the conference today that are going to focus exclusively on these things. So I'm not going to try and duplicate what the experts can do. So to get started, let's first talk about configuration. So like I said before, I think we're all familiar with configuration as building Spring Boot apps. We have our application.properties or application.yaml file. And our configuration typically lives inside our application. But in a cloud environment, it's better to take the configuration outside of the application itself and put it in some kind of centralized store. And the reason behind that is because imagine the situation where you just want to change a single property of your application, but you don't really want to have to change that code or change that properties file, build the jar, and then have it all go through the whole deployment pipeline, resulting in downtime just to do that. By having configuration served from a configuration server, we can eliminate that problem, right? So you can go ahead and change the configuration in the configuration server, and then when the application wants to refresh its configuration based on some schedule or whatever, you can do that without having to result in bringing down the application and redeploying it. So our config server can support configuration stored in an infinite number of stores, but the ones that we support by default are a Git subversion, the file system, or HashiCorp's Vault as well. So you can put your configuration in any of those things, and the config server will serve the configuration to your microservice applications from there. Now the config clients, your applications, will retrieve the configuration when the application starts up. And like I said before, can be notified of when your configuration changes. So you can go ahead and change the configuration and then manually tell your applications to go ahead and refresh its configuration when you see fit. Or you can have the config server notify the microservice applications that the configuration has changed and go ahead and refresh the configuration automatically. So it depends on what strategy you want to take, but it's up to you. That can happen in a dynamic way. So service discovery. So you're going to have a bunch of microservices that make up your cloud native app, and they're going to want to communicate to each other. But it's typical in a cloud environment that these services can both change location, where they're maybe the URL that they're located at, the data center they're located in, the region they're located in, the number of instances that are available. That can change from hour to hour, or can change from day to day. So it's very dynamic, right? And service discovery helps all the components of your cloud native application figure out, hey, what's the current URL for the service that I'm interested in talking to? How many instances are available? Where is it? What's its status? Is it up, down? Is it unhealthy? That type of stuff. And then use that information in order to make a request to that service. So We support a couple of different backends for service discovery. The one that's probably the most popular to use is Netflix Eureka, but we also support using Zookeeper and Console as well. So routing and messaging, this works alongside service discovery. Your apps are going to want to talk to each other, right? Like we said, we're going to want to make requests between the different microservices. Those requests can be made via HTTP or some type of asynchronous messaging protocol as well. And what's going to happen is your microservice is going to talk to the service registry service and figure out, where is this service that I want to make a request to located, and then use some form of routing or messaging to make that request. And we can do that from a HTTP side of things using Netflix's Ribbon or another open source project called OpenFeign. And if you're interested in using asynchronous messaging, we support RabbitMQ and Kafka. The cool thing here is that we can introduce some type of client-side load balancing as well. So based on the information that we get from this service discovery service, we can decide whether, which instance of a service that we want to talk to. We can take like a round robin approach. We can take like we can make a request based on latency, that type of stuff. So that can all happen client-side as opposed to happening, deploying some type of infrastructure in your environment or relying on some kind of external load balancer as well. So API gateway. So like I said before, whether you're going to have a public API or it's just your own internal clients that are going to be making requests to your cloud-native application, you're going to want to have some API gateway to help insulate those clients from the microservices that make up your cloud-native application. And that's because, again, the dynamic nature of a cloud-native application, the number of services, the type of services, the services themselves that you have today can be quite different tomorrow. A popular example is you might have some microservice that grows so large that you decide you want to split it in two. And now you have that one microservice that was one API request before, but now is now going to be two API requests. And if you have your clients talking directly to your microservices, that can result in a lot of problems. So an API gateway can help kind of insulate that dynamic nature from your clients that are using your cloud-native application. So here we take advantage of another Netflix project called Zool. And funny story, I was watching Ghostbusters on the way over to San Francisco from the East Coast. And every time they said Zool, this is all I could think about. It's kind of stuck in my head at this point. So Zool will leverage the service discovery service as well and some of that client-side load balancing using Ribbon that we talked about a second ago. And then there's a fairly new project, actually brand new project in the Spring Cloud ecosystem called the Spring Cloud Gateway. And we're going to talk a little bit about this, hopefully. This is a new project that's based on Boot 2.0 and some of the reactive stuff that you just saw in the keynote. Like Phil was talking about in his discussion as to whether you choose a reactive type of project or you don't choose a reactive, and there was the ducks and the cats and they were swimming and flying and all that stuff. We take advantage of that reactive nature in our gateway project because we don't really know the service that we might be talking to in the back end from the gateway. Is it going to respond fast or slow and whatnot? So we can help get a lot more throughput through the gateway by taking advantage of that reactive nature in Spring Boot 2.0. Circuit breakers. So circuit breakers, a pretty cool and very useful feature in Spring Cloud. This is going to help protect your microservices from any type of failure that might happen. So they're typically used whenever you're going to make some type of network request, whether that's to an HTTP request to another microservice or maybe a request to a database, something that has the potential for, one, failing outright, or two, being extremely slow, for some reason, right? In the cloud, we are running on infrastructure that we typically don't have control over. It can misbehave. We don't really have control over when that's going to happen or what's going to happen. And so we want to protect ourselves from that. And circuit breakers do that. And the way this works is if the request that we're going to make fails, either due to a timeout or just outright blows up in our face, if that happens a certain number of times, the circuit breaker will be tripped, and then the request won't be made anymore. It won't actually make that request. And that's going to help us, one, do two things, right? Protect ourselves, right? So we can actually return back some data to our clients that might be somewhat useful as opposed to just throwing an error back at them. And two, help maybe alleviate some of the stress on the downstream services that are having a problem. So if the downstream service is just overloaded with too many requests, by implementing a circuit breaker, we're going to alleviate some of that stress downstream. And like I said before, we can return some potentially useful data to our clients. Like, for example, if the circuit breaker is tripped, we can return the last good cached data that we had. So something comes back to the client as opposed to just some type of error message. And then what will happen is that periodically we'll let a certain number of requests go through to kind of test to see if something's actually working again. And then based on whether that's actually successful or not, we might flip the circuit breaker and then allow everything to go through to the actual downstream service again, or not, based on what happens. And we use Netflix's Hystrix project to implement that. So tracing, like I mentioned before, very useful for cloud-native applications. You have a lot of different microservices. They're going to be talking to each other. You want to be able to trace requests from one to the next to the next. And we do that using a project called Spring Cloud Sleuth in Zipkin. So we're briefly going to take a look at this. It's very useful when debugging latency issues or just problems in general. You kind of have a centralized place to go to look and see your logs, see latency information, maybe see some dependency graphs, et cetera. That's extremely useful. And then CI pipelines and testing. So yes, we want to build, test, and deploy our various services, right? That's going to be important. And Spring Cloud Pipelines is an opinionated pipeline for either Jenkins or Concourse that can be generated automatically for you based on your projects. That's pretty cool stuff. I'm not going to dive too deep. We're not going to dive into that project today. But there is a session, and I have a list of all the relevant sessions later on by my colleague Marcin that wrote all this code that he will deep dive into that in much more detail than I could anyways. So I'll direct you to that at the end. And then Spring Cloud Contract, we'll take a brief look at Spring Cloud Contract. I think contracts are super cool because it helps you really mock out dependencies between your microservice applications. And you'll know exactly when you make a change, whether that's going to break something, a consumer of that microservice. So it's really cool stuff as far as testing is concerned. And we're going to take a look at that today. So that's all my slides. So we can get to the cool stuff now, which is the demos. So all the code, and actually you can get the slides as well up here too. If you go to this bit.ly URL, which is bit.ly/beginner s1p, that will bring you to a GitHub repo, which has all the code that I'm going to show today, as well as a link to the slides up on SlideShare as well. And I'll give you a chance to take a picture if you want. Everyone pull out their phones, take pictures. Great. OK. And obviously, this is all going to be available to you anyways. Oops. Once this conference is over. So I guess let's take a look at the repo, right? So this is the repo that bit.ly URL is going to bring you to. I wrote a very rudimentary README that kind of describes what's going on here, but I'm going to explain it to you, so you don't really need to read it right now. There's a couple of folders here. I'll start with the kind of obvious ones. If you go to the Start folder, this is the basic starting point for all these applications that we're going to start with. They're just plain Spring Boot apps. There's nothing special going on here. If you go to the Complete folder, this is actually those applications turned into, or they're the same applications but are using Spring Cloud at the end. So this is what we're going to end up with at the end. And then there's two other folders. First is this Beginner's Guide to Spring Cloud Config. This is the configuration that our config server is actually going to serve up to our clients. So when I talked a lot about configuration before, this is the YAML configuration files that are actually going to be used by our applications. And then this other folder here, I'll describe a little bit. So there's a cool project that's part of Spring Cloud that I didn't mention before called the Spring Cloud CLI. It's a very useful developer tool, and you'll see why in a second. So we talked a lot about like using service discovery and Zipkin for tracing and the config server. And when you're doing development, those pieces of infrastructure, they're like pieces of infrastructure, then they're pretty much the same for all applications. So Spring Cloud CLI allows you to basically spin those up without having to build out those applications yourself because they're exactly the same typically across all apps. And this is just providing some configuration for the Spring Cloud CLI. So this config server.yaml is basically going to tell the CLI where our configuration lives. So you'll see here it's living inside this Git repo, which is the Git repo that we're looking at right now, inside this folder that I just talked about before, which has our YAML files. Okay? So that's all. I'm sorry, I see people straining their eyes. That's all that is. Okay? So what I'm going to do now is make this a little bit smaller again. And then I'm going to jump over into the IDE here. So these are the 3 projects. I'll describe a little bit about what this amazing application that I have here is going to do, and it's going to absolutely blow your mind because it's so cool. Basically, there are 3 projects. Like I said, right now they're all just basic boot applications. There's nothing special happening inside them. There's this greeting app, which basically is going to return a greeting, something like hello. But you can optionally, in this application, there is a controller that, has 2 endpoints on it. So the root endpoint is just going to return a default greeting. You can see it's reading from this properties file or this properties class. Or there's a / language code or locale, whatever you want to say, endpoint, which will return a greeting based on your locale. So like if your preference is for Spanish, it will return hola. If your preference is German, it will return allo, right? So basically the greeting for that locale. This properties class is just a configuration properties class that's going to read some properties from our configuration, which looks like this. Again, nothing amazing happening here, just kind of basic stuff. All right, the name project is just going to return a name, right? It's very similar to the greeting project. It has a single endpoint at the root, which returns a name, reading from some properties, and those properties look like this, okay? So our name right now is Ryan. And then there's this web project, and this web project basically talks to the greeting and the name project and returns some type of greeting by concatenating those 2 together. So again, there is a single REST controller here, and again, at the root of that, it basically calls out, actually it does something a little bit silly here. Well, not silly, but it tries to resolve the locale based on the request. So it's going to look at the accept language header from the request and basically try to determine what your locale is and then return a greeting based on that. So it will call out to the greeting service with that locale right here. And then also call out the name service to get the name and append those 2 things together and then return that as a result of making the request. And then we have 2 classes here, the greeting service, which as you can see is basically just using a REST template to make a request with the greeting service, and same thing here with the name service, okay? So nothing magical happening here, right? Very basic stuff. I'll show you what it looks like. So if we start these apps up here. And we go to localhost 8080. You see hello Ryan, right? So if I go ahead here and in my Chrome preferences, I change my language preference to be German, it will change to allo Ryan, right? And if I do the same thing here and say I like Spanish as well, you see hola Ryan, okay? Nothing magical happening, right? Very basic. But this is going to provide kind of the basis for demonstrating some of the stuff we talked about in the slides. So there's a couple of things we want to do here to these projects. First, we want to remove the configuration out of the projects into a config server. We want to register each service with a service discovery server. We want to, there's some nice logging stuff that's going on here in these projects, right? You probably noticed it in the controller or whatnot. These log messages would be great to centralize all that logging using sleuth and tracing and Zipkin and stuff like that. And in the web project, when it's making requests off to the greeting and name services, it'd be great to take advantage of service discovery and use things like Ribbon and OpenFeign to call those services, so we get some of the client-side load balancing and the stuff that goes along with that as well. So we're going to kind of transform these projects, and I'm going to coin a term here, Spring Cloudify them, and do that over the next couple of minutes or so. So let's start by adding a bunch of dependencies that we need. So this is our POM. It's basic, nothing crazy going on. I already have the dependency on our Spring Cloud BOM, and we are using the latest Edgeware release, which was just released a couple days ago. I can't really remember. We do so many releases. It wasn't too long ago, though. And we're going to add some dependencies here. So the first one we're going to add here is Spring Cloud config client. So that's going to get our config stuff going. Then we're going to add dependency on Spring Cloud starter sleuth, and also Spring Cloud starter Zipkin. And then lastly, we're going to add our Eureka dependency for service discovery. So Spring Cloud starter Netflix Eureka client. Ugh. Client. Ugh. Auto completion fail. Just do it for me, please. Oh, IntelliJ. Why? 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 All right. I think that's right. And yeah, so that's all the dependencies we're going to add. As far as code changes, this is going to really blow your mind as far as what we're going to do here. We're going to add an annotation here called enable discovery client. And this is automatically going to register this service with Eureka. And we're going to remove all the configuration, right? So our configuration is going to come from our config server, so we don't need this anymore, right? And just to show you, if we go and look here, this is the same configuration, but here in GitHub. But our client's going to need to know or tell the config server how to identify itself and what configuration to pull down. So we do that by setting this property called Spring Application Name. And we're going to name this service greeting. So this does two things. This is going to tell the config server, when we make a request to the config server, we're going to identify ourselves as the greeting application. And the config server is then going to look for configuration with the name greeting, which we have here, right? Okay, so that's how it knows which configuration to serve up to the application. And the other thing that's going to do is give a name to our application. So when our application registers itself with Eureka, it registers with this name greeting, right? So we have a way of identifying the service then that's registered. So that serves a twofold purpose. And then the other thing we're going to do here is we want to take advantage of the Spring Cloud tracing features from Sleuth and Zipkin. And so we want to send whatever logging that we have here off to Zipkin so we can visualize that stuff. And the way we do that is by creating a sampler bean. So we're going to create a bean here that's going to return a type sampler. And oops. We're going to return a new always sampler. And this basically is just a sampler that's going to send everything, no matter what, off to Zipkin. You can obviously implement other types of beans of type sampler that are more selective as to what they send off to Zipkin, right? So if you don't want to send everything off, which is probably a good idea, you probably want to do that. But there's an always sampler that's provided by Sleuth that does that by default. Now, as far as the changes that we're going to make to the name application here, that is going to look almost exactly the same as what we did to the greeting application. So the same exact dependencies that we have. So we're just going to go ahead and do the same stuff here. And then we're going to, again, remove all the properties here. And we're going to set Spring application name to the name. That's the name of this application. Kind of repetitive, but poor choice, I guess. And then we're going to say enable discovery client. And we're going to create that same bean that we had before. All right. All right. And that's done. All right. I don't think I've missed anything. So now we're going to take, I talked a little bit about the Spring Cloud CLI and starting Eureka and the config server in Zipkin. So let's go ahead and do that. So Spring Cloud, and then you just type Eureka, config server, and Zipkin. And it's going to go ahead and start up these services for me. There's other things that the Spring Cloud CLI does. You know, it starts up, you can start up Kafka and some other kind of infrastructure pieces as well. And you can do some other cool things with the Spring Cloud CLI as far as having it start up your own applications and all kinds of cool stuff. So if you want to play around with that, I highly suggest you take a look at it. So it should be starting up everything here. So it looks like everything's up and running. So if we go now to localhost :8761, this is Eureka, really large. And there we go. So you can see both the config server and Zipkin actually registered itself with Eureka automatically for you. That's great. So Eureka is up and running. The config server should be running on localhost 8888, and this is all configurable by default, but these are just the defaults we use. So for example, if we hit greeting/default, this is our configuration, right? It looks a lot like this here, right? So this is the actual API request that our config clients are going to make when they talk to the config server. So it looks like that's up and running. And then, oops, if we go to localhost 9411, that will be Zipkin. This is a Zipkin UI up and running. This is where all our tracing information is going to go. So we got all that infrastructure stuff up and running. So let's go ahead and just restart the greeting in the name application here. And there's a couple things I just want to point out to you here, or one important thing I'll point out to you here. If we look at the logs here when these applications start, we'll see that they're reaching out to the config server, right? So it's fetching config at here, right? And then it's pulling down some configuration, which is this configuration here, right? So that all looks good and what we expect. And again, if you guys see me screw up typing or coding or whatever, please yell at me, because that's just going to be better for everyone. So the applications are up and running. So if we go to localhost where they're running here, oh, actually, I'll show you one quick thing first. So we do that. Did the name application not? I didn't restart it, did I? There we go. The other thing you can see here is it actually registering with Eureka. So you see here registering application with Eureka. Oops. here. Registering application with Eureka with status up. That's basically signaling that it registered. So if we look at Eureka now, we should see the greeting and name applications all registered with Eureka. So that's all great stuff and all what we expected. Now, the web application is going to be a little bit different than the greeting and the name application. So we'll start off with the same dependencies that we added to those two applications as well. So we'll start off with all those same dependencies, and we're going to add a couple more. So the additional ones we're going to add are a dependency on Spring Cloud, Starter, Netflix, Ribbon. Oof. Where's everyone? Come on, someone should be yelling at me. And now we're going to play with silly auto-completion not working. So Ribbon, we're also going to add, this is probably easier if we do this way. We're going to add Feign. And then we're also going to add Zool as well. Zool, Netflix, Zool. All right, so we're going to use this as an API gateway of sorts as well, or at least show you how that would work. Now, we're going to do the same stuff we did before, so we'll say here at enable discovery client, and we're going to add that same sampler bean. And I like to copy and paste, so it reduces the risk of me screwing something up. And then there isn't any configuration for this application per se, but it's still a good idea to give it a name. So if we say spring.application.name is web, okay. Now, as far as other changes, we're going to change here. So in the service classes where we are actually making requests out to the greeting and name services, you can see here we hard-coded the URL to the service, right? But that's not what we want to do. We have the magic of service discovery and ribbon and all that stuff, fun stuff, and we want to take advantage of that. So you can use ribbon alongside your REST templates that you're all familiar with today, and the way you do that is just by adding a single annotation here. So we're going to add the @load_balanced annotation to this REST template, and all of a sudden it's going to take advantage of ribbon. Great, and service discovery, so we don't really have to do much, right? The one thing we're going to have to change here, we don't have to change, but if we want to change, if we want to take advantage of service discovery, we no longer want to specify a URL, the location of the service. We want to specify the service name instead. So instead of saying localhost 9090, I want to make a request to the greeting service. And what happens is we have an interceptor that gets added in front of that REST template that looks at the URL and gets the information from the service discovery service and says, hey, is there any service with the name greeting available from the service discovery service? And if there is, it's going to replace that URL with the URL that has been registered with the service discovery service instead. So if the greeting service is no longer running at localhost 9090 and instead running at localhost 8181, I don't need to go ahead and change my code. That's just going to magically come from the service discovery service instead. All right. And because we're using ribbon alongside that REST template, if we have more than one instance of that service running, it will load balance between them. Okay. By default, it uses round robin load balancing. We could use another algorithm if we wanted to as well. So for the name service, we could do something similar. So we could go ahead and use ribbon and a REST template if we wanted to. But I want to show you how to use Feign as well. It's another cool feature, so we don't have to use this REST template anymore. But what we do have to do is define an interface So we're going to define a static interface here called name feign client. And this interface is going to have one method that's going to return a string called getName. And the feign implementation in Spring Cloud takes advantage of the REST MVC annotations. So that's how we define the request that's going to be made to the name service. So we say at request mapping, and then we say where the request is being made, and this is just a get to the root, so it's pretty simple. But if it was a more complicated, post or with specific, query parameters or whatever, you could define that using your typical request mapping annotations. And we're going to add an annotation to this interface called feign client, and we're going to define the service that this feign client is going to use from service discovery, and that's the name service. And we're going to add an annotation to this service class called enable feign clients, so the feign clients get picked up. And then we no longer need this stuff here. We're just going to say we're going to have a private name feign client variable. Oops. And then we're no longer going to take in a REST template. We're going to take in a name feign client. And we'll set that all up here. Feign client equals name feign client. All right, and then we're going to return here. Oops. Name feign client dot get name. And that's it. And I believe this is just IntelliJ trying to be smart. Yes, it is. It's not so smart. OK. And I think that's it. Did I add the bean? Yeah, I added that. Zool, right? So if we want to make this a kind of a API gateway proxy type of situation, taking advantage of Zool, we can just say enable Zool proxy. And that's going to automatically do that for us. And I'll explain a little bit about that in a second. But I think that's all we have to do for the web application. So let's just restart this here. Oh, yes, I forgot about my tests. So I was a good developer and I wrote tests, like they said in the keynote, right? But now, since I broke I changed the constructor for the name feign client, name service, I need to go ahead and fix that here. So instead of mocking a REST template, we're going to, I'll make this bigger. We're going to mock name feign client. And this should be name feign client. And instead of, we're going to mock the name feign client dot get name. Have it return Ryan, and this is going to be name feign client. All right. Now we're going to come back to the test in a second, but because that's important. We should be able to run our app at least. So once that all starts up, we should see in Eureka, we now have the web service registered in Eureka as well. And if we hit our web service, we see Hola Ryan, as we expect. And I can still go ahead and change my language preferences here so to prove that everything works, which is great. So the applications all work. Some things to take a look at. Zool, right? So I added this annotation, this at enable Zool proxy here, right? And that did something, right, you'd expect. And what that did is allow me to proxy from the web application to the greeting application, for example, right? So I could say /greeting, and it will hit, it's going to proxy the request off to the greeting service, okay? And I can do, /de, and it will return allo instead, or I can do /yes, right? Hola. I can do the same for the name service, right? And by default, what enable Zool proxy is doing is it's taking advantage of service discovery. So it's looking at the services that are registered from the service discovery service, and it automatically creates paths inside your application for them. So it sees that there's a greeting service, so now there's a /greeting endpoint in our web application, and sees that there's a name service, so there's a /name service, right? Name endpoint in our application. And there's a lot you can do here. I'm not going to dive into it. You can, once you have Zool on the class path, you can alter those paths. You can add filters to dynamically change the requests that are being proxied across, stuff like that. Some things that you would expect to happen in an API gateway. But I won't dive too deep into that. I just wanted to show that real quick. Also, we can take a look at some of the tracing information here. So if I go over to Zipkin and I start changing these parameters here, we see some of the tracing information has been sent here. Okay, you can take a look at this stuff. You can see that there was a request made to the web service. This is how long the request took. This is how long of that time. This is how long it took to make a request to the greeting service. This is how long it took to make a request to the name service. You can click on these and see more information about the requests. Okay. You can also, there's a nice little dependency graph that gets made here. So you can see the web service actually talks to the name and the greeting service. That would be useful, much more interesting when you have a lot of microservices deployed. And you can see some of that logging information that we were looking at before looks a little bit different now. You'll see, like, when I log some of this stuff here in the console, that there's this extra information along with the logs, right? So this information basically is what's called a trace and a span ID. This is how we're tracing requests from one service to the next, to the next, to the next. This true just means that it was something that was actually sent off to Zipkin to be displayed. If it was false, like this has to do with a sampler, right? You might create a sampler that doesn't send everything off. You could see whether something was actually sent off to Zipkin or not, just based on that, right? Again, there's another session dedicated to Sleuth and Zipkin exclusively that goes into a lot more detail than I will here. I'll give you that information at the end of today's session to point you to that stuff. OK, is there any questions about what we did up until this point at all from anyone? Yeah. So like off to a database? Yeah, so as long as you add Zipkin to your, or Zipkin and Sleuth to your class path and enable the sample, some type of sampler, then it will trace that information as well. Yeah. OK, so I briefly mentioned tests. I had a bunch of tests, right, that were here. Which are located here. And each one has a test. So I'm going to fix some of these tests, right? Because we're no longer, I changed the code, so we're no longer talking to localhost, right? I need to make these mocks behave a little better, right? So this is the name service. Oh, sorry. This is the greeting service. This should be greeting, right? This should also be greeting. This is just making sure that my tests are mocking the right stuff. So if I run this, that should hopefully pass. Of course not. Which one is failing? Oh, because I have a typo. Come on, guys. Oh, you probably can't see that, right? That was my fault. All right. I do, yes. OK, now this should pass. No, it's not going to pass. No. Oh, I still have a typo now. All right, I'm really off. All right, there we go. Does that look right, guys? All right, thank you. Magic of pair programming. All right, that passed, right? Same thing here. Nope, we fixed that one already. Here, this should be, actually, this should be, we need to do something different here. This should be greeting. we need to mock bean something else here, which we need to mock the name feign client bean. So this should be name feign client dot get name. All right, and this should now pass as well. We're being really good developers right now. Okay, all our tests passed, that's great. Now let's say I want to change something about the greeting service, right? So instead of in the greeting service, I don't want to return hello as the default greeting. I want to change it to be yo instead, because we're very hip and cool. Okay, so I'm going to go into my tests. In my test properties, this default greeting here is right now hello. I'm going to change it to be yo. Okay, and then I'm going to go over here and I'm going to do the same thing in my test to make sure that my default greeting is yo, right? And I'm going to run my test in my greeting application, and it's going to pass, we hope, right? And then I would go off to my, now that I've changed my test, I'd go off to my properties here, and I'd do the same thing here. I'm not going to do that just because it's not necessary for the demo. But you get the point, right? And then I go ahead and redeploy my service, and great, everything's working. But the problem is that my consumer of this service, the web application, is going to be affected by that, right? Because it's expecting the default greeting to be hello, right? But I just changed it to yo. But if I run all my tests in my web service here, they're all going to pass still, right? Even though there was a breaking change, right? I might depend on the fact that that's going to return hello, and it's no longer returning hello, but I don't really know about it, right? Someone went off and changed the greeting service, and I don't know about it, and all my tests are green and passing, and I think everything's great. And meantime, we're going to go deploy the new greeting service, the new version of the greeting service, and things are going to blow up. Right? This could be a big deal, right? It's not such a big deal in this application, but it could be a really big deal in a more realistic application. Not that this isn't realistic. So this is where the magic of Spring Cloud contracts comes in. I have my other ID here, and this is just the same this is all the projects just loaded from the complete directory. So in the complete directory of that Git repo, this is all the same changes I just made, plus all the Spring Cloud contract stuff that I didn't show you, but they're using Spring Cloud contract in a test. So the way Spring Cloud contract works is we go ahead and under our test resources directory, we define a bunch of contracts. And all these contracts do is basically specify a contract about the endpoints, the APIs that my service has. Right, so I have a bunch of contracts here that say when, for example, when you hit the root of this service that we're going to return hello, or when you hit the root, or when you hit /de, we're going to return hello, right? Same thing with the other ones, right? For /en, we return hello. For /es, we return hola, right? So these are contracts about the behavior of our application. And what Spring Cloud Contract does is it's going to basically, based on these contracts, automatically generate tests for both the greeting application itself, but also stubs that our consumers can run that dictate the behavior of this service without actually having to run the service. So it will start up a server, basically when our consumers run these stubs that have realistic endpoints that return realistic data based on the expectation of that service. So for example, when the web service consumes these contracts and the tests run, a server is going to be running that's going to have these endpoints running that returns this data based on this contract. So if I go ahead and change these contracts and adjust my greeting service accordingly, but that breaks one of the consumers, they'll know immediately because I've broken the contract and their tests are going to fail because the contract's changed, right? So let's make the same change here, right? So in our greeting application, I'm going to go ahead and I'm going to change this property from hello to yo. I'm going to go ahead and change my contract as well to be yo, right? And for a reason that I'm not going to explain, there's also this other spot that I need to make a change to. Here. And if I go ahead and run my test here, this should pass. And then the other thing I'm going to do is I'm going to, oh, it doesn't pass. Why did I? Oh, because I actually forgot to change this. Now it should pass. And the other thing I'm going to do is actually run my build. And the reason why the build is important, so I'm going to go off here, and I'm going to go to, the reason why the build is important, so I'm going to run Maven, clean, install, is because what Spring Cloud Contract is going to do is build a jar file that gets installed into, in this case, my local Maven repo, but it could be any Maven repo, containing those stubs based on those contracts that my consumer applications can then pull that jar down, and that's how it knows which stubs to run, right? Which endpoints to run. So you'll see here the last line that gets printed in our build is installing this greeting blah, 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 dash stubs.jar into my Maven repo. And now other, this could be, a remote, obviously, repo, but in this case, it's my local Maven repo. And now this can be used by my consumers. So I made the changes to the greeting service. All my tests pass, but now in a realistic scenario, I'm gonna go ahead and push those changes up to my Git repo. My pipeline's automatically gonna run, and then all my tests are gonna start running, right? So the web service, for example, is gonna run its tests. So when the web service goes ahead and runs its tests, we'll see, like, unlike before, some of these should actually fail because it's using those contracts. And those contracts have changed, and my expectation of what those contracts were has also changed. And for some reason, they all passed. Why? That should not be true. Let's do some quick debugging, folks. It's probably better if I run just one of them. Make it easier to figure out. Oops. Come on. Huh. I don't know what I did, and we're running out of time, so assume that they would fail. They should fail, and I don't expect to know why. It could be a Maven thing, but just for the heck of it, I want to do one thing. The one thing, yeah, so we have like 5 minutes, so I want to leave enough time for you guys to ask questions. The one thing we didn't get to talk to about is the gateway service, and that's okay because there is an entire session dedicated to that, and I assume this build is going to pass as well because it's going to make me look like a fool. Anyways, yeah, not every demo goes perfectly, I guess. But anyways, yeah, so I'll leave some time for your questions. These are the other sessions that are related to the stuff I talked about. There's the gateway session on the Spring Cloud Gateway later today at 4:20 to 5:30. Continuous deployment to the cloud, talks about our Spring Cloud Pipelines project. And then that is tomorrow. And then on Thursday is our 2 talks on contracts, Spring Cloud contracts, as well as Sleuth and Zipkin. Those are all on Thursday, so those are other sessions to check out some of the stuff. So with that, I'll open up to questions for you guys. If you have any. If not, enjoy. Yep.
How does the main client compare with the REST template in terms of customization? Do you do a lot of the same things you do with the REST template?
Yeah, so anything you can do as far as with a Spring MVC annotation is basically how you customize the request. So I'm not particularly sure what you mean by customization. Do you mean by customizing a request or like customizing?
Like if you have to do like authentication or if you have to add custom headers to the request?
Yeah. So all that stuff is taken care of using the Spring MVC annotations. Okay. Someone else had a question, I thought. Yep.
I mean, this might be for the other session, but how did those trace IDs get into the Fame client and the REST template client?
So that's kind of just the magic of.
Locals or?
Yeah, Marcin will have to how we implemented it, but yeah, it's just automatically happens when you add the package to the class path, and then yeah, so it detects what you're doing. Any other questions? Yep.
What if there's another service called name or greeting? So how is the service name has to be unique? So that
Yeah, so if there's another service that starts up with the same name, it will think that it's the same, another instance of the same service. So if I, for example, created a completely different boot application and gave it a Spring application, spring.application.name with the name greeting, for example, and my other greeting service was already running, when that registered with Eureka, it would just register with Eureka. You'd see there'd be 2 instances of that service running in Eureka then. So you see how this up and then parens 1, it would be 2, right? So yeah, that needs to be unique for each service that you want, or else it's going to consider it the exact same service. Okay. Yep.
So for Zoom or Cloud Gateway, right?
Yep.
You have normal patterns for authentication and authorization.
So it's not particularly taken care of by Zool or the gateway. There's no code that is specific to authentication or authorization in those projects. We have a Spring Cloud security project, which does take care of authentication that will integrate with the gateway, or not with the gateway, but with Zool at this point, that you probably want to take a look at. Right? So there's nothing specific in Zool that actually is going to do authentication magically for you. It will proxy the correct headers, et cetera, down to the downstream services. Yep. Yep. Any other questions? All right. Thanks, everyone, very much.